Hello, my name is Don Bowman and I'm from Agilicus. And here I'm going to talk to you about an opportunity that we ran into with a municipality in Ontario. We're going to talk about how we interpreted their challenge, and then we're going to talk about how we responded. This was something that was presented at MISA Infosec Ontario 2019. The challenge and the opportunity. So the municipality said, our staff work outside. Majority of our people are working with not a desk. They're working in trucks and roads and so on. And the second is, if we could build a mobile, bring your own device friendly applications that work on any internet, we'll be more efficient. And we've observed that some key business requests are very simple to build online apps for, instead of customizing complicated ERP software like PeopleSoft or Maximo. But we're worried about security. The risk is huge to maintain public-facing applications. What should we do? So we also want two-factor authentication for everything, but Active Directory is very expensive, and many of our staff are contractors. They're not employees of us, they don't have desks, and they don't have accounts in Active Directory. We've observed that cloud servers are very much cheaper than building a local data center, but we want our data to stay in our data center, not just for data sovereignty, but also for privacy and security. But above all, we just want the apps to be available to every user in any location, on any device, anytime. So we're presented with this opportunity. How do we help? First, we decompose the problem. I listened to what the municipality said, and then we applied engineering discipline to it. So first, they talked a lot about anywhere. We want the applications to work anywhere, on any device, any user, any location. But the data has to stay at home without exposing Active Directory to the internet. We don't want to expose any databases to the internet, and we don't want to be constantly reinventing or reconfiguring the firewall. Each new application, there should be no reconfiguration needed. If we look at any device, well, all modern devices support a browser. In fact, about 70% of all devices and users are using Chrome, about 10% are using Firefox. But interestingly, 50% of all devices are mobile. So any new application, if it's going to be used by anyone, anywhere, needs to support mobile and Chrome. Angular, React, and Vue are new frameworks to support variable screen sizes. It makes it very convenient and easy to make a high-quality application that works on any device. We need to work with the lowest common denominator, which is JavaScript or HTML5. We need to avoid any OS or browser dependencies. For example, in past years, people would get locked into Internet Explorer. Let's talk about the any user problem. If half the workforce are contractors without Active Directory accounts, and all users need to have strong, simple security and login, we couldn't emphasize enough simplicity. We cannot be constantly changing passwords for these users or having them write them on Post-it notes. We don't want multiple accounts. We want single sign-on. Everybody should have one sign-on for all things. It needs to be very easy to manage users. We want the team leads to be able to manage their team. We're constantly hiring people and they're on temporary basis. We need to be able to control who can do what, when, per app, without worrying about all of the internal security of those applications. If only we could treat identity decoupled from Active Directory, we think there'd be a good solution here. Let's talk about the problem of identity. If we have staff and contractors using different systems, we need what's called a federated solution. Here we're showing a system that's using both Microsoft Active Directory, but also Google for login. We want to support multi-factor natively. This means that identity needs to be internet accessible, identity needs to work with all applications without reworking them, and be able to use two-factor or multi-factor authentication. The other observation is that the system or the application itself has an identity. This application is going to be coming back home to this database. We need to make sure it is who it says it is to avoid a security breach of something laterally traversing within the cloud. If only we could treat Active Directory users and social users uniformly for ID, roles, and permissions, it would be much simpler to solve this problem. Any location. So most workers don't have desks. They don't even have access to the facilities or a desktop PC. They work in the field. Any location implies any internet connection. It can't be just a special one or a VPN. This concept is sometimes called Beyond Corp by Google or Zero Trust by others. Any internet implies we give it zero trust, encrypt it all. Doesn't matter where it is. If we talk about the data staying at home, what does that problem mean? Well, in technical terms, this is sometimes called a hybrid cloud or platform as a service model. Not all protocols are web. There's a lot of technologies out there that allow very simple firewalling of HTTP based on headers, but here we're using applications that are wire-level protocols such as Oracle Database. We need to guarantee that the right app reaches the right resource. Apps that don't otherwise can't get out, and the wrong app cannot reach the resource. We don't want to make the firewall complicated. We don't want any rules per application, no ongoing changes. This implies that we don't want the firewall to have complicated layer 3 or layer 4 rules changing by IP or any sort of URL-based rules. The other thing that was interesting is there were a set of non-stated needs. So nobody talks about needing a system to be reliable, but it's implicit. We need to be disaster resilient, so no single point of failure, and geographically spread. We need to be secure and have great audit, because something's going to go wrong. We want to be able to see what it was and when, or at least prove that nothing has gone wrong. We need to be cloud native. The system needs to be automatically self-healing and orchestrated because we want it to be modern and efficient without a complicated set of people tasks involved in every upgrade. We want to be self-enabled. What this means is that the municipality can have a production and staging environment and do their own updates. They don't want to be constantly calling the vendor to deal with that. We want to be self-enabled. The team lead needs to own their own users. So the person who manages the parks, they're hiring people. They need to be able to say, okay, this person has access to this application. We want to reduce work. We don't want any complicated team training. It's no good to bring online a new solution and then increase the amount of workload if we're trying to decrease it. And we need to reduce cost. Overall, budgets are tight, but above all else, security needs to go up. So how did we solve this problem? The first thing we did is we introduced a protocol called OpenID Connect, and then we federated the identity from social, in this particular case, Google. Almost everybody in the world has a Gmail address because it's based on Android or Chrome. And then we federated that with Active Directory. All of the municipality staff had an account there, and then we seamlessly stitched those together. We accessed the Active Directory via VPN because there was no desire to expose it to the internet, and we used a service called Active Directory Federation Services to expose the OpenID Connect. We introduced a workload identity-based firewall. This means that we can control with cryptography and say this application, the backend, is allowed to talk to this internal resource, and that secure identity is not based on layer 3 or layer 4 coordinates such as IP address or port. To do this, we introduced a protocol called SPIFFE, which is a production workload identity. It involves putting a cryptography header on each session, and we did that by upconverting from wire-level protocols like Oracle into WebSocket to allow us to enrich it. We introduced the concept of user role RBAC web application firewall between the user and the application. This means that we can securely put any application on the network knowing that there's a universal security layer in front of it. We don't have to worry about internal flaws or breaches within that application. It's handled at the web layer between the user and it. And then, this is one of the most interesting bits, we observed that all of these individual applications were Angular.net on Windows, each running on a separate virtual machine with vSphere and a set of licenses. We very simply shifted these to Linux container so we could run them in Kubernetes in a cloud in an orchestrated environment. This dramatically lowered the cost and dramatically increased the flexibility. Everybody wins. So let's talk a little bit about that concept of universal users with multi-factor authentication. The first thing is when you're putting a new application or a new system online, you don't want any more spots storing your passwords. You want them stored in exactly one spot, the original source of truth. So many systems have passwords in the clear or with very simple hashing, and they get breached. And then, well, we know what happens next. So here, our system, we hold the concept of identity, but we don't hold the password. It's solely held in the upstream system, in this case, Microsoft Active Directory or Google Gmail. For multi-factor, OpenID Connect natively supports this. So for users who've enabled two-factor on their Google account, and if you haven't, I encourage you to go do that right now, it automatically works in the web world. We enrich with groups and roles. For example, we have a concept called IT admins or truck drivers. The individual department leads choose how they organize their teams. They create a group, and then they assign users into it. And then very simply, they can assign those groups roles and say, well, the truck drivers can read their timesheet, and then they can edit this. It's all up to them how they make it work. The observation that identity applies to the workload, this is the back end. There's so much thinking around how a user is identified that we often forget that the application has multiple pieces and they also need security. So we take each network flow, TCP or UDP, and we upconvert it into what's called a WebSocket, which is a special type of HTTP carrying TCP payload. We then use something called a JSON Web Token, or JWT, added with a header called SPIFFE, which is a cryptography header with assertions. Those assertions are around identity. I am this backend application signed by this, and then the firewall acts on that identity. This means we never need to reconfigure it. It knows what to trust based on a cryptography chain of trust rather than a complicated set of rules that people could get wrong over time. We use a concept called mutual TLS. TLS is that protocol HTTPS runs over, sometimes called SSL. The most common way that you use SSL or TLS is one-way authentication. You know for sure that website is your bank, but the bank has no idea who you are until you log in. We use a concept called mutual TLS, and this means that A knows B, but B knows A. It's TLS on both ends. The user to application layer uses a web application firewall acting on HTTP, and then the user ID and URL are both available at that time, and that allows us to say user Don is in group B is able to get to this backend application. The app to application, so the east-west flow, uses TLS and SPIFFE, and then the app to the exposed resources being inside the building, is policed based on that. And then, above all, we use public cloud. So here, the application we built is running in Google Cloud on Kubernetes, and this is a multi-tenant system running a container orchestration. It dramatically lowers the cost, but more interestingly, it dramatically improves the reliability and availability. We're running in 3 zones, zone A, B, and C. Those are different buildings. This means that if there's a failure in a backup generator or power grid, that there's no loss of service. In fact, it's not even observable. Interestingly, you'll see that each application is always running at least 2 copies. So application 1 is running in both zone A and zone B. There's a load balancer in front. This means that the user will never see an outage even as we do a rolling upgrade or even if an entire zone goes down. All management is entirely automated and self-healing. There's no user intervention required. It's instantaneous and automatic. We also do automatic TLS certificate allocation and renew. This means that every application has its own TLS certificate. There's no use of wildcards, which are very dangerous, and no use of private keys that are shared everywhere, causing potential risk. Each application has its own on-demand certificate. And then there's a complete logging, audit, SOC, and SIM. Every single action, everything that every user ever does, there's an audit record for, and it's attached back to them. You can go back through that and see. So, did we achieve the goals that we were given up front? Yes, I think we did. The applications are accessible anywhere, to anyone, on any device. The security is higher. There's multi-factor authentication, as you see on the right. There's complete audit, no password stored anywhere, a full web application firewall. The cost is lower. We've reduced the licenses. The team's got more capacity to get things done. It's very simple. You can just publish and go anytime, updates and staging. We've dramatically increased the efficiency. We've dramatically increased the availability. The end users can use the applications anywhere with a very simple login experience, common across all of them, and our security is high, the data stays at home, everybody's happy. Thanks very much, appreciate your time, bye-bye.